So hi friends, now let's see the solution for 2017 Mht-Cet mathematics question paper. So first question is our as shown, that is the number of principal solution of tan to theta equal to 1 is. So for tan to theta equal to 1, the number of solution principal solution for tan to theta equal to 1 is. So first of all, tan to theta equal to 1, here the tan to theta value is positive. So for this we have the tan to theta is positive in two quadrants, the first and third quadrant. So the principal solution for tan to theta equal to 1, which is positive, is number of principal solution is 2, because it is a positive value, and for that positive value we have first and third quadrant. For the number of principal solution will be 2. Okay, next is the second one, which is the objective function. We have given the objective function, that is z is equal to 4x1 plus 5x2, and the and is subject to 2x1 plus x2 greater than or equal to 7, and 2x1 plus 3x2, 2x1 plus 3x2 less than or equal to 15. And also we have given that x2 less than or equal to 3 and x1 comma x2 is greater than or equal to 0, has the minimum value at a point. So we have to find the point at which it has a minimum value. So to find that, first we have to draw the graph, because there are not much shortcuts regarding it. So we have to draw the graph of it, and we have to locate the points, and we have to find the minimum value at the corner points. So after taking the table for these two equation and after drawing the graph, you should find the corner points of that graph. Here you can see there are 4 corner points, and also you have to remember that it is not necessary to draw a graph neat and tidy, because it just it just had to be understandable by you. So you have to draw it fast and thorough, as you have to match the time of your CET paper. So you have to be thorough with your question paper. So as you can see here, 2x1 plus x2 is greater than or equal to 7. So we have to take this side portion is greater than or equal to 7, and the next is 2x1 plus 3x2 less than or equal to 15. So in this case we have taken this portion and x2 less than or equal to 3 and this downward portion. So overall this portion will be our shaded portion, and corner points for this shaded portion are this 4 point, that is 4 comma 3, 3 comma 3, 3.5 comma 0, and next one is 7.5 comma 0. So we have to put this 4 points in that z equation and find the minimum value. So after putting this all 4 points in that z, we come to know that the point 3.5 comma 0 has minimum value. If you are having doubt with it, then you just go and put this value in this z equation, and you can find that this 3.5 comma 0 is the point having a minimum value of z. So the minimum value of z at that point is 14. So our answer is 3.5 comma 0 and 3.5 comma 0. So the y coordinate of that point is 0, so it lies on x axis, therefore the point lies on x axis. Okay, so the point lies on x axis. Next question, we have given that if z1 and z2 are the coordinates of points of trisection of segment joining the points a of 2, 1, 4 and b of -1, 3, 6, then we have to calculate z1 plus z2 equal to. So in this case, the z1 and z2 are the z coordinates of the point of trisection. So point of trisection means this is z1 in this case divides the AB into the ratio 1:2. So we can write z1 also equal to 2a bar plus b bar divided by 2 plus 1, that is 3, and we can find its coordinates as. So there is another method for this using coordinate geometry, but you can also use the reference of vector, which will also be an easy way. So here we get z1 is equal to 2 into the a bar. A bar is 2 I cap plus j cap plus 4 k cap, plus b bar is, what is b bar, minus I cap plus 3 j cap plus 6 k cap, the whole divided by, sorry, the whole divided by 3 is equal to 2 into 2 4 I cap plus 2 j cap plus 2 4 is 8 k cap minus I cap plus 3 j cap plus 6 k cap divided by 3. So we get 4 minus 1, that is 3 I cap plus 2 and 3 is 5 j cap, and 8 and 6 is 14 k cap divided by 3. Okay, that is the z1 bar. So now next is z2. So in this case the z2 lies in between b and z1, that is it is like a midpoint of b and z1. So we have the coordinates of b minus 1 comma 3 comma 6, and we have the now coordinates of z1 2. So z2 lies in between z1 and b, so z2 is midpoint. So for z2 we have z2 coordinates as 3 by 3 plus 1 divided by 2 comma 5 by 3 plus 3 divided by 2 comma, next one is 14 by 3 plus 6 divided by 2. It's nothing but a midpoint formula. So we get 1 9, this is a 9 plus 8. So we get the coordinates as 1 14 by 6 32 by 6 after solving. So the z1 plus z2, this is z coordinate, coordinates z coordinates, the addition of z coordinates is equal to, so we have to find 14 by 3 plus 32 by 6 is equals to how much. So that is 14 by 3 plus 16 by 3 dividing by 2, we can get 16 by 3. So it is nothing but 30 by 3 and answer is 10. So our answer is z1 plus z2 equal to 10. Okay, there is another method also for this, which is nothing but a similar one by internal section formula. So from that also we can get the same answer. So in fourth question we have to find the maximum value of f of x equal to log x. So here x not equal to 0 and x not equal to 1. So first of all we have to differentiate this equation. So we take f dash of x equal to, by differentiating x into 1 by x minus log x into 1 divided by x square by u by v derivative formula. So we get 1 minus log x by x square f dash of x, and we know that f dash of x is equal to 0 for maximum or minimum value. We take f dash of x equal to 0 for maximum or minimum value, because the slope of tangent at that point becomes parallel to x axis, so it becomes 0. So we get 1 minus log x divided by x square equal to 0, that is 1 equal to log x, which is nothing but log x equal to log e, that is x equal to e. Now putting this value, which is a maximum value at f of x, we get the value of function as of e equal to log e by e, which is nothing but 1 by e. So our answer is 1 by e. So next question is of integration, that is integration of 0 tan inverse x dx from 0 to 1. So here we have to solve the integration with the help of multiplication rule. So it is quite simple problem. So we have to solve it by multiplication rule. So in this way answer as tan inverse, sorry here 1 is remain, I think so, in a hurry. Here tan inverse 1 is there. Okay, so minus 1 half, so it is integration 0 to 1 x, that is 1 into dx minus integration of 0 to 1 divided by 1 plus x square into dx, so which is nothing but 1 half into tan inverse of 1. You know that what is tan inverse of 1? Tan inverse of 1 is nothing but pi by 4, and 1 half into pi by 4 minus 1 half into x minus which is the integration of this is nothing but tan inverse x full 0 to 1 limits. So it is pi by 8 minus 1 half 1 minus tan inverse 1, which is pi by 8 minus 1 half 1 minus pi by 4. So we get our answer as pi by 4 minus 1 by 2, which is nothing but pi minus 2 by 4. Okay. So in next question we have to find the statement pattern for which the negation P and Q is equivalent to. So in this case we have to draw a truth table, that is P, Q, negation of P, P or Q, P and Q, and negation P and Q, P or Q or negation of P, yeah, and also P or Q and negation of P. So you can also take P and Q implies P and P or Q implies P further next, but I am showing up till here only. So because the answer is in between P or Q or negation P and P or Q and negation P. If you go through the textbook clearly, you will know why there is the answer between this. Okay, so let's see the truth table. Q, this one is similar to, is equivalent to P or Q and negation P. As you can see, the elements here both are same, that is F, F, T, F, false, false, true, false, 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 true, false. You can take in either 0, 0 and 1 also as per your convenience. So our answer is P or Q and negation P. So in the next question, that is 7th one, we have given that g of x is inverse of f of x, that is g of x is equal to f inverse x, that is here we can write f of g of x is equal to x, which is nothing but a same, and we have given that f dash of x equal to 1 upon 1 plus x raised to 4. Then we have to calculate g dash of x. Okay, in order to calculate g dash of x, so let us take the derivative of this term, that is f dash of g of x into g dash of x is equals to 1. So we have the f dash of x as 1 upon 1 plus x raised to 4. So putting the value of g of x out there in x value of x, we get that the function value as 1 upon 1 plus g of x raised to 4 into g dash of x equal to 1, which is a quite simple, that is now g dash of x is equal to 1 plus g of x raised to 4, and from option we get our answer as 1 plus g of x raised to 4. So in next question we have to find the inverse of this matrix. So in order to find the inverse there are many shortcuts, but I must prefer you the shortcut which is mostly used for the calculating inverse. Now in this case first we calculate the determinant. Let us see it is singular or non-singular matrix. Okay, the determinant of A is not 0 now. So to calculate the inverse of matrix, let us find now the adjoint, because A inverse is equal to 1 upon determinant of A into adjoint of A. So first part, that is determinant of A, we have calculated. So let us find now the adjoint of A. Find the adjoint of A. Now here, in order to find the adjoint of A, so we have to take we have to write first all the matrix as it is 1 0 0 3 3 0 and 5 2 minus 1. Okay, we have to write the first two rows as it is afterwards, so that is 1 0 0 and 3 3 0. Then we have to write the first two columns this side again, it is 1 3 5 1 3 0 3 2 0 3. Then we have to leave the first row and first column, and we have to go with solving the 2 by 2 order determinants. So this you can see here we have to go on solving with this 2 by 2 orders. It is 1, here it is 1. Okay, now we can see here it is minus 3, here it is 3, here it is 6 minus 15, here it is 0, it is minus 1, it is minus 2, here it is 0, again 0, here it is 3. So we get our matrix as minus 3, then 3, minus 9, 0, minus 1, minus 2, 0, 0, 3. This is our matrix. So we have to take the transpose of it. After taking transpose, we will get the adjoint. So after taking transpose, that is minus 1, minus 3, minus 1 and 3, the diagonal elements remain the same. Here it is 3 0 0, here it is minus 1, now 0 out there, minus 2 and 0, and this is our adjoint. Now this is our adjoint. So we get our A inverse as 1 upon determinant of A, that is minus 3 into minus 3 0 0 3 minus 1 0 minus 9 minus 2 3, and on dividing we get our answer as so in next question, ninth one, we have to find the value of alpha plus 1 by beta is equal to. So we have to first solve the integration and then compare with this sin inverse beta x, alpha into sin inverse beta x plus c. Then we have to find alpha plus 1 by beta equal to. So first of all, let us solve the integration, which is equal to integration of 1 upon root of 9 minus 16x square dx. So it is 1 upon root of 3 square minus 4x whole square dx. So taking 1 by 4 outside, it is 1 upon of 3 by 4 square minus x square dx. So now it is in the form of 1 upon root of a square minus x square dx, which is nothing but sine inverse of x by a plus c. So we get 1 by 4 sine inverse of x by, that is 4x by 3 plus c. By comparing it with this equation, we get alpha is equal to 1 by 4 and beta is equal to 4 by 3. So alpha plus 1 by beta is equal to 1 by 4 plus 1 by beta, that is 3 by 4, which is nothing but 4 by 4. The answer is 1. So in next question, that is the 10th question, we have given a triangle with a certain coordinates O, A and B, and they have asked to find the joint equation of a median and altitude of that triangle. So let us consider OD be the median. So median divides this part AB part into equal, OD divides AB into equal parts, that is the D is the midpoint of AB. So coordinates of D are coordinate of A, x coordinate of A plus x coordinate of B, that is 1 plus 3 divided by 2, and y coordinate of A plus y coordinate of B divided by 2, which is nothing but 4 divided 2 it is, and it is 3, 2 comma 3, the coordinates of D. So now let us find the equation of OD. We given O as 0 comma 0. So to find the equation of OD, let us first find the slope. So what is the slope of OD? Slope of OD is 3 minus 0 divided by 2 minus 0, that is 3 by 2. And if you have seen my earlier videos, then I have told how to find the equation with the help of slope. So here slope is 3 by 2, so therefore its equation is 3x minus 2y, and here the passing point at 0 comma 0, therefore it is 0. Therefore 3x minus 2y is equals to 0 is the equation of median. And same as the of altitude, altitude is perpendicular to AB, so slope of OC is equal to minus 1 upon slope of AB. So what is slope of AB? Slope of AB, let us find the slope of AB. Slope of AB, which is 4 minus 2 divided by 3 minus 1, which is 2 by 2, which is nothing but 1, and slope of OC is minus 1. So in case of this, for minus 1, we have the equation as minus x plus y equal to 0. So minus x plus y equal to 0, that is x plus y equal to 0, the first equation, and the second one is 3x minus 2y equal to 0. On taking the product of these two equations, we get our answer as our answer. So here we have to find the value of k. So here we are given the function f of x is equal to tan of pi by 4 plus x raised to 1 by x. For x not equal to 0 is k, and if it is continuous at x equal to 0, then we have to find the value of k. So let us find the value of k. So first of all, if it is continuous at 0, so now it is, if it is continuous at 0, so f of 0 is equal to limit as x tends to 0 f of x. So f of 0 at x equal to 0 is k, so k is equal to limit as x tends to 0 tan of pi by 4 plus x raised to 1 by x. So we get limit as x tends to 0, 1 plus tan x divided by 1 minus tan x raised to 1 by x, which is tan a plus b, is nothing but tan a plus b. Now by using 1 raised to infinity form, so 1 raised to infinity form, so we get e raised to limit as x tends to 0, inside the bracket 1 plus tan x divided by 1 minus tan x minus 1 into 1 by x. So we get our answer as e raised to limit as x tends to 0, which is 2 tan x divided by 1 minus tan x into 1 by x. So solving limit at, so here solving limit, we get 2, here 2 taken outside, tan x by x into limit as x tends to 0, 1 divided by 1 minus tan x. So we know that limit x tends to 0 tan x by x is 1, so e raised to 2 into 1 into 1 divided by 1 minus tan 0 is 0, which is nothing but we get our answer as e square. So k is equal to e square at that point. Here you can see that if a into adjoint of a is given, and it is given that for invertible matrix a into adjoint of a is equal to given, then we have to find determinant of a. So if we see that a into adjoint of a is equal to, if we take tan outside, then it is nothing but 0 1 0 0 1. So it is nothing but a unit matrix. So it's a unit matrix, so its value is I, and it is 10, which is nothing but a determinant of A. You should remember that A into adjoint of A is determinant of A into A inverse. So A into adjoint of A is equal to determinant of A into A inverse, but it is given that A inverse is an invertible matrix, so it is a unit matrix. So determinant of A into I, so we get our answer as determinant of A is equals to 10.